Okay, so for the insecure deserialization lab on JavaScript, I'm going to have you do this. I'm going to actually have you set up the vulnerable server. And the reason why is because I want you to see the effects of the deserial. So you're going to be both on the client and on the server. And then you're going to see that the exploit that you develop on the client has an effect on the server. And you're going to be able to check that, yes, it does have remote command injection on the server as the effect. And that's basically, I think, what is the, it's basically two ls commands, one before you inject the payload and one after you inject the payload, that shows that you have gotten some file on the remote server to be created. So that's the goal of this lab, and just to do it within the JavaScript environment. And in order to set this thing up, I'm going to have you create a virtual machine on Google Cloud Platform, install Docker. So I don't know if not, I don't know how many of you have used Docker before, but part of this thing is for you to get practice using Docker and to see what Docker provides you. So that's what we'll be doing. As it turns out, I didn't have the foresight to actually start all of this stuff, a vanilla version of this ahead of time. So what I'm going to do is I'm going to walk through the steps quickly of creating the VM, installing the Docker stuff, and then getting all of these things up and ready. So that's what we'll do. The first thing is to go to Compute Engine, which you've done before, create a virtual machine instance, name it DVNA because, yeah, well, actually, this doesn't matter. You can name it anything. US West 1, F1 Micro is the cheapest thing you can specify. It specifies 1804, but really anything that runs Docker is fine. So, your favorite operating system is fine. Uh, um, it's just that the installation of Docker is different on 1804 than 2004, I think. It's slightly different. So that's the only reason why I specify 1804 here. And then because we actually are running a web server on this particular virtual machine, you need to allow HTTP traffic to this thing. So that's what I'm going to do here. I'm going to create an instance. Actually, I'll leave that running just in case I do something awful, or in case my thing freezes like this, maybe. All right. So I'll do, this is DVNA in class, and then I'll go US West 1B. And then this is the older stuff, which is the cheapest stuff. And then F1 Micro. Oh, you know what? I'm going to delete this pretty quickly, so I'll go whole hog. I could actually, so one of the things with this, so let me get back. You can actually deploy a container directly on this virtual machine instance. And you will see that there is a container that's going to be run on this particular virtual machine. If you want to skip that step, when you do this, deploy a container image directly onto the virtual machine instance, the container owns everything. And any of the ports that it brings up are the ports on the physical machine that are brought up. There isn't a level of indirection, so it's basically running on bare metal when you do this thing. Well, bare metal, it's still a virtual machine being virtualized, but it's actually, it's convenient, let me just say this, to have that, but we're not going to run it in this mode. You would do this in the cloud class. We do this directly on the VM instance. But in this case, I actually just want to go to Ubuntu and then do 1804. And then that's fine. So that I need to allow HTTP traffic over here. And then I'm good to go. I'll just create this thing. And then we'll go back to the code lab. What I'm going to do is I'm going to access the external IP address. Well, no, I am not going to do that. I'm going to note that I get an external IP address, and then I'm going to SSH into it because nothing is running on this virtual machine. It doesn't have a web server or anything. I have to set up the vulnerable website, so I'm going to SSH into it first, and it takes a little while. If you first click SSH and it doesn't give you anything, if it gets a connection failed, you just have to wait a little bit longer. Like this thing will fail if, like, as soon as you bring it up and then click on it, it might fail. But you just have to have some patience. which is, I don't have a lot of patience, but in this case, I have to deal with it. And then what you're going to do is you're going to run these commands. What the first one does is we're actually going to use Docker to download. So the Docker site has basically an apt repository for you to install the Docker packages, like the Docker Linux packages. So that's what we're doing. We're gonna download the public key for this publisher for packages, and then we're gonna add it to our list of trusted repositories. We're going to do an apt update to update the trusted repositories. And then when we do an apt-get install of the Docker Community Edition, it will know to search for all of the trusted repositories, and it will find that this particular repository does have a Docker CE, and then you'll install it straight from Docker. So that's what this stuff is doing. I'm going to copy that. Since I got my VM here, I'm going to run this stuff. And then, so just give you a crash course on Docker. Docker gives you an image, and the image name is here. And this is like GitHub. Docker Hub has a way of specifying names. And so the AppSec security folks have the Docker Hub ID of AppSecCo. And then they publish a damn vulnerable node application is basically what this is. And so we're just using the SQLite version of DVNA because we don't want to have to install MySQL. And then this is the name of the container that I want you to bring up. So this is the image. This is kind of like your binary image, but then this is actually the actual instance of the thing running in memory. This flag says, I want to run a web server. Now, typically, this container brings up its website on port 9090. So if I had created a virtual machine and said, this is the container I want to run on it, then port 9090 would have the web server running. And then I would have to create a firewall rule that allows port 9090 in order for me to access it. But I created a virtual machine that says allow just HTTP access. And so what I want to do is I want to route the HTTP traffic to the port 9090 on the container. And that's what this thing is doing. You know, map port 80 on the host to port 9090, which is what the web server here is running. And then I say, Docker, run all of that, and then put it in detached mode. I want to put this in the background so that I can just, you know, move on. I don't want an interactive shell on this or anything, just background the thing. And this is like, put it in a daemon mode. So that's what that thing, it detaches the thing and runs it in the background. Okay, so that's what I'm going to do next. Oh shoot, it didn't install Docker CE. Sorry, I have to wait. I'm going to pause the recording. And so you see the Docker's been installed, and now what I'm going to do is I'm going to run that container, and it knows it doesn't have this image locally, so it goes and it gets it from Docker Hub, and then it pulls all the different layers, and then it runs it in detached mode. And then you can see this here, and then if you wanted to, you can see the thing running, and you can see that local port 80 is mapped to 9090. What else can I do? I could do a wget. And you can see it's running here, so that's good. And then I can go back to the virtual machine instances and then click on this external IP address. And you should be, the server should come up. So this is the first part of the lab, is to get you some experience running this. The lab has you create a new account on the application. So that's what I'm going to do next. Register a new account, enter my full name, create a strong password, and then go to insecure deserialization. And then this is the scenario. I have a legacy import product And I'm gonna specify the products I want to import using a JSON-like data format, and we're gonna show you this next. So this is the URL. They give you the format of this JSON object. It's basically well, it's not a JSON-like format because this isn't actually JSON. This actually is this actually don't know. I don't remember JSON enough. I thought JSON has to be a curly brace first. But this is an array. So this is like a JavaScript array that we're specifying the data in. It's a JavaScript array, and each array has an object, and the object has these key value pairs: name, code, tags, description, and it's for a gaming console. So that is the format of the objects that you get. And so what the Code Lab has you do, you go through here and it has you test out the application. So this is the, we're going to see in the, so you copy and save this in the file system, and then you upload this thing just to test that it works. So this is the thing that we're going to upload. You see, I have the Nintendo Switch and the PlayStation 4. Well, I have the Switch. I don't have a 4, but that's what I have here in my inventory. And then I'm going to upload this, choose a file, go to games, upload this thing, and then you see I have those things loaded. So that's the data format that we're going to specify here. I'm going to go back to, whoops. Back to this page. I'll need that again. So the next thing you do is you check out the code, and then I have you figure out the vulnerable package. It's easy enough to Google. Well, it's easy. So the first thing is for you to poke around the source code to find the place where the vulnerable code exists, and you'll look through some Node.js files that might look juicy. And then you'll be like, well, where is this bulk product upload happening? Because you know that that's where the vulnerability is. And then you'll see, well, what packages does this thing require? So in JavaScript, it's the require keyword. So I just have you navigate the source code just so that you can get used to looking at source code. And then once you find the code, once you find the package that looks bad, you should just make a mental note never to use that package ever again. For a web application. So the package is used for other things, but you just shouldn't use it with a web application. Let me say that. And then you're going to take that package name and you're going to search for the actual vulnerability. And there's a really good article that describes the vulnerability that you can read. I'll talk a little bit about the vulnerability. There's a special function that's involved, and actually you'll probably see it later on in this walkthrough, but it's a special function that this package will invoke when it does the deserialization, and then you can override that function and then cause all sorts of havoc. And so you will see the function there. And then what I'm going to show you in this particular class is how the actual package does the serialization, and then give you an example of it deserializing. And so I'll have you find the vulnerable package, require it, and then give it some object to serialize. So that in this case, the malicious object is to require the child process package, so basically install it, and then to execute a shell command, which is ls/ in this case. Well, so when you serialize JavaScript objects, you can not only serialize data, but you can serialize code, the actual function definition. And this is what we're doing. This is not actually executing code initially, but what we want you to do is to create a function that, or declare a function that what it does is run this code. So this isn't actually getting invoked yet. But you would want to eventually invoke this function. And so this is saying do an ls of the root directory. And we want the output of this so the callback after this thing finishes, and this is the typical way you would write JavaScript, because JavaScript is like targeting a single thread of operation. So every time you specify something to run, you say, this is the callback after that thing is finished. And so the callback, or the thing that's run after the thing is finished, is to take that function, get its error, standard out, standard error, and whatever error code it has, and then just take the output and log it to the console. And then what I'm going to do is I'm going to serialize that thing using the code, and then figure out what this thing looks like. So that's basically what this does. So this is just copying the code as we saw before in that code lab. Oh, it's already run, but let me run it again. And then you can see that the serialized version of this has something that looks like this, which is a function name. So this is a special name that turns out is the Achilles heel of this thing. And then you can see that the code shows up. So, it's not much different than the actual deserialized version, but it does have this thing here. Okay, the next thing is function expressions. The problem with JavaScript is that when you declare a function and you instantiate it, JavaScript has the ability, and this thing is called, oh shoot, I didn't update this code lab. Hang on one second, because I actually have a link to this that I want people to actually look at. Or I want you to actually look out. JavaScript has this, I think this immediately invoked function expression. I think that's what it's called, but I don't want to get it wrong. I just updated this thing, and I did not reload this thing. So let me, immediately invoked function expression. So, and you do this by, as you declare this function, you basically put the parentheses for function invocation right after it. And then you can see that you can actually invoke the function as you are defining it. So I want you in a replit to see this thing happening. So that's what the next replit will show you. So this is that code. I'm going to run it. And then you're basically see hello G actually ran. So here I'm just defining function f, so it's not going to run. But when I define G, the function actually invokes. Not only do I define it, I invoke it. And what I want you to do is, so when you look at the type of f, you can see that it's a function, but the type of G is a number, because this thing is returning 1. And so let's see here. The next thing I want you to do is actually invoke f. So you would do that. But then if you actually give the expression G, it will automatically invoke this thing. So this is the problem with JavaScript, is that you can define it. Once you put this here, as soon as this thing gets defined, it will execute the actual payload. And so that's what we're going to do next. Because if you serialize this, and then upon deserialization, you will get code execution in this particular framework, I should say. Okay, let me go to the next thing. So now you have that payload from the beginning. You can just easily edit the thing to put the parentheses back. And you know what? I just deleted that thing. That's really, oh wait, it's actually here. Okay, so what we have done is the payload from the very first replit, we just take that and we create a string out of it, because really this thing requires a string to do the unserialize. In the first thing, I did the serialization and I printed it. To tamper with it, I'll create a string out of it. And in this case, I'm using the single quotes to delimit the string. And so in order to escape out the single quotes that are actually in the string, I have to put backslashes there. And then I also want to immediately invoke this expression. And so what I'll do is I'll do the function invocation right after this. And when I deserialize this payload, you'll see that I'll get I'll be listing slash on whatever system I run this thing on. So again, and this is a Node.js REPL, so you can see with the JS there. So when I run this code, you can see that this is the container that's running this JavaScript environment. This is what it has in its root directory. And then you can poke around and see your container environment here. Okay, so that is the next step. And so this is a rhetorical question. Is this something you would like to have happen on the server running your web application? Yeah, no. That's not what you want, because this is actually, this is actually like when you go through the source code, you will see the source code basically doing, oops. You will see the source code doing this operation on the payload that that is given to it, the file that you upload. It's just going to do an unserialize, and then this allows you to just put this in as a payload and then get code execution. Okay, well, ls/. All right, so now we're going to create an exploit because that's what we do in this class. I want you in a REPLit to create an object that basically we call it a touch. This is called touch serialize me. And if you look at this this object, it's basically going to go into the file system and create a file. It's basically a null file. But I want you to substitute your Odin ID here because I don't want, well, I mean, I want you to personalize the execution of your code lab so that you can put it for your lab notebook. And then this is a version that doesn't automatically execute. You're basically going to generate the serialized version of this. And then what I want you to do, you'll get something that looks like this here on the bottom. So I have that in a REPLit. And you already see this. So this is the version of this. I'm going to touch this file. And again, it doesn't invoke it yet, but I'm going to print it out. I'm also going to create another object where I'm just going to do an ls of /temp. So this creates a file in /temp. And then this will just create a directory listing of /temp. And then I'm going to get the serialized versions of both of these. So that's the next step of this code lab. And you can see this is serialized version of the touch. This is a serialized version of the ls. So that's your next step. And then finally, you're going to add the function invocation to both of these things. So then your serialized payload that actually does the immediately invocable function expression is then created here. So then I create the string with this single quote. I backslash, and this is just taking the output of the previous thing, and then backslash the single quotes here, and then do the invocation at the very end. And then likewise for the ls payload, I'm going to do the same. I'm going to backslash the single quotes to create the string, and then here I also need to include. So if you notice in this definition, the null function, because I don't care about the output of the touch command, this is much simpler to do, but then I have to go back to the original output for the ls because I need the console output to be dumped. I want the console output to be dumped in order to know that the file has been created. So that's why I put this here. So that's the ls payload, and then the touch payload underneath is similar. I don't know why these things are out of order. Yeah, so that's the touch payload. And then these are the two payloads that I'm going to run. And then what I want you to do is run the ls payload and then see what you get back. run the touch payload, and nothing will come back because it's just going to execute, and then run the ls payload again to show that you in fact have modified the file system. So that's what the next replit is going to do. So here is the ls payload, and you can see it's just doing the exec of /temp. It's getting the console.log output, and it's performing the invocation, and then it's doing the deserialization. So this is the container that's running the that this thing is running in. So then if I run this, you can see that there's nothing there, so that's fine. And then I'm going to create the file and then run this thing. And then you can actually go into the shell on this replit and go, hey, look, the file is there. But that's no fun because we're on this thing. And then you can actually just run the ls again. So let me comment this out. And let me just run the ls again. And then go back to the console, run this thing. And then you can see the file shows up as well. So that is the next step of this vulnerability. And the coup de grace is to actually upload this thing onto the server. You are first going to bring up a shell on this container. So we set this container up into detached mode, but we can get an interactive shell on this thing. So that's what I'm going to do next. So I do sudo docker exec. The name of the container is DVNA, and I want to run bash. And so this is me on the container running around. And if I do an ls/temp, you can see that it's got the npm stuff in /temp running. So we're going to need this. So this is keep this thing running because we're gonna upload some malicious malicious data, and then upon deserialization, it's going to run the code that's there. So let me go to the next thing. We can just take our payloads, the touch payload. In fact, that's the only one I want you to do. You can do the ls on the server itself. Because you could actually do this, but you wouldn't be able to see the output on the web app. So what I want you to do is just upload the touch payload, so you can go back. You can go back here, and you see this payload right here. This is the thing that I want you to copy and paste into a notepad file, and I've done that already. So I've done that here. This is the notepad file, and I want you, because the application is looking for an array of objects, this is an object, and so this is the array of objects. So you need to add the square brackets to this thing, otherwise the Node.js will crash if you don't give it this array. Well, the web application will crash if you don't give it this. It will still execute this though, but we don't want the thing to crash. We actually just want the thing to execute and then return. So that's basically what we're doing. This is the exploit that you see. Let me then go back into the application, and I'm going to choose this file. I'm going to say, give me that exploit. And then I'm going to upload this thing, and it'll not complain, but nothing will get uploaded. And then what you would do is you would go back here, and then you would see, whoops, sorry. You would see that file got created on the server. And then that's where you're done for this lab, because as soon as you have that code execution, you own the whole thing. So you could set up your web shells and this, that, or the other. Okay.